Hi, my name's Nathan Glover, and today I'm going to go over my fifth video for my project HandMap. In today's video, I'm going to mainly focus on discussing my current implementation and some of the tests that I've performed. I'm just going to briefly discuss what we went over last time. We looked into how OpenCV would load onto mobile devices and managed to get it working in Unity 3D. We discussed a method for distance mapping using an object as a scale, and I also outlined the structure of my thesis. In today's video, the plan is to look at the idea that I had before in regards to finding out just how effective distance mapping is when the camera taking the image isn't directly overhead of the object. I also want to discuss another method of object detection using dlib learning libraries. And finally, I'd just like to demonstrate some real-time results of what I've got so far. dlib is a learning library that is commonly used in machine learning and the analytics space. It provides sort of a number of interfaces that allow the training and classification of certain data sets. It comes with pre-trained classifier for facial recognition that generates a 68-point YX coordinate map that basically is the structure of a human face. And this set of data is called a facial landmark index, but I'll cover it more in detail in the next slide. So when we talk about landmarks, we're talking about key points of interest that make up a typical facial structure. So if you have a look at the image on the right with all the little points, those are indices representing points on a typical face. And this was trained using a iBug 300W dataset, which I've linked in the references. It can be seen as sort of like an overlay on the detected face in an image. So if you have a look in the bottom right-hand corner, that's a picture of me running the facial classifier over myself, and you can see that it picks up all the sort of major traits. This information is really useful because it can be used for detecting things like blinks. So if specific points in that facial landmark map disappear or get closer to one another, you can detect blinks or winks or mouth opening and closing. And it's also the method used in a lot of facial swap apps. So you can map the eye points to another person's eye points and sort of swap the contents of those locations across. But having a facial swapping classifier doesn't really help me for my project, so I needed to implement some form of custom classifier using the dlib framework. So what I did was I downloaded a dataset of hands, similar to how we did with the HAR classifications, except I used a much bigger dataset for this one, about 500 hands. And the other benefit of this version compared to HAR classification is that we don't need negative images. So I obtained this dataset from the link in the reference. There are much more than 500 hands. There are gigabytes and gigabytes and gigabytes of images, but I sort of opted to use less and just to confirm that I could get it working. At this point, I used a handy tool called ImageLab that was built alongside of dlib that allowed me to sort of draw bounding boxes around the key areas for the classification in my images. For the testing purposes, I only mapped the hand. It was a very time-consuming process, but if you wanted to get, I guess, more technical and a lot more accurate, you could map every subcomponent of the hand, so all the different fingers. This would make it a lot better later on when you go to actually try to detect sub-parts of objects, which is something I will probably need to do in the future, but at this time I opted not to because it would have taken a long time. Once this was complete, I saved all this information out to an XML representation of the information, and I ran it through the train object detector.py script that came with dlib, and it built my detector.svm classifier. The final step was just to write a short piece of code that used OpenCV and dlib and a function called simple object detector to find out whether an object exists within a frame. And then I just drew a bounding box around the output image in real time. So I'd just like to briefly go over the dlib hand classification sort of in real time to show you the outcomes that we get. As you can see, it's quite accurate. Considering my image set was only about, I guess, 500 images and they were all in one orientation, I'm quite happy with just sort of how responsive it is. Another sort of benefit to it is that this sometimes works, you can draw something that kind of looks a bit like a hand. hand, and that is a terrible hand, so I'm not liking my chances. If I move it up or down. Okay, I guess not. For the magic of editing, we're back. So I sort of sketched out a better hand, and as you can see, it is detected, and it doesn't have sort of the color characteristics that a hand normally has, so it kind of works a lot like the HAR classifier in that respect. And you can also see in the bottom left-hand corner, I've included the how do I put it? The landmark map that it's using to detect the object. As you can see, it doesn't really look like a hand, but as you train it more, you'll find that that landmark map will start to resemble the object that you're trying to track or mimic. The next idea I wanted to focus on was based on the previous distance mapping idea. I really wanted to be able to run it in real time instead of just on individual images, and sort of just find out how big of a difference or not it had taking measurements from angles. I'm already sort of assuming that it will have a massive difference, but I just need to test that. So I started by restructuring my code to make it run in real time, and I also just limited it to only show the I guess the lines and distances for the center points of all my target and reference objects. I just wanted to briefly touch on two fairly important lines of code. One is the width variable. This is the width of the leftmost object in the image, and I measured the blue cube and it came out to 3.8 centimeters, or approximately 1.5 inches. And the second line is the biggest hack I've ever written in my life, and that is I wasn't sure how to pull apart the original sort of array of data, so I've temporarily only displayed data aligned with the color pink, which is the center points of each of the images. I have to stress that this is temporary and I do plan to fix it very soon. Hi, I just wanted to quickly demonstrate the distance mapping in, I guess, a real-time, real-world example. So what we have here is we'll draw a start reference point. So the way the program operates is it takes the far leftmost object of a decent size and uses that as a reference point. So for example, this will be our reference point. Then if I go and draw a second point here, and you might already see it starting to work, you'll find that the left object is our reference point. Now I'm the reference point, but that left object is our reference point, and you have a distance map between those of 6.4 inches, which won't be completely correct because we are looking up at it as an angle, and I'll have to explore other options for that, but it does also handle multi-object, so we can use other shapes as well. It'll take the middle point of the shape. Triangle is going to be weird because it's going to put a box around it, but it takes a sort of the best estimate of the center point of that image and provides you with a vector outward. And yeah, we can do other things too. And I'll demonstrate one other thing. Size does actually matter for this. So if we do a small little object, it won't get picked up because I've actually set the minimum threshold for an object, basically the size that it has to fit before it gets recognized. So you can see that that's probably still too small. If we slowly increase it, we'll eventually get to the size where the program does eventually recognize it. So yeah, this has just been a short demonstration of what it's capable of doing now, and yeah, cool. Now that you sort of have a good idea of what I've been doing based on the demos, I'd like to go over some of my plans for the future. I would really like to integrate the distance mapping in real time with my angle mapping in real-time code. Optimally as well, I would also like to have it so that I wouldn't have to have the reference object on the far left of my image. And I will probably use the color detection that I used in my angle mapping code to find the reference point, i.e. the blue sensor box. Finally, I'm excited to announce that my project is a finalist in the WA-ITTA Insight Awards for Best Tertiary Student Project of the Year. So I'll be presenting my progress soon to a panel of judges, and here's hoping that I'm successful and I'm able to present my research at the awards night. If you are looking at doing hand or object detection, be sure to check out some of the references I've linked to the facial point annotations and hand image databases, especially if you're doing hands. They've been a really big help, and I would highly recommend them. Also, if you have any questions, want to get involved, or just want to check out what I've been doing, I put everything up on my blog, which is handmap.github.io. That is a tongue twister. Or flick me an email at nathan@glovers.id.au, and I will be sure to message you back.